Hello,
Hello.
hello.
Hi, Manjush.
Hi, Maru.
Hi, how are you?
Good. How are you?
Yeah, I'm great. Thank you.
Thank, thanks.
Okay. So, shall we start?
Yeah, sure. Your voice is too low.
Is it? Is it better now?
Yeah. Now it's better. Correct. Yeah.
Um, okay. So, I saw your email. I sent you the link to the videos again. Can you just access it and let me know?
Yeah. Now, just now I saw that email. Basically, I was planning to do it 2 3 days before and just to go through all the things. But
Okay.
unfortunately, that you didn't respond because I lost the link that you have given to me.
Oh, sorry about that. Yeah,
So I
yesterday
could I
actually I
could
was way too busy. Couldn't actually check my email.
yeah. It's okay. I will cover up.
It's okay. You can come back to with questions, to me anytime. So that's not a.
Yeah, sure.
And by the way, uh, did you go through any other stuff? Like, did you write any piece of code? Do you want any topic to be like touched again or something before we move forward?
It's if I have any doubt, then actually I couldn't go through that video. That was the main problem. So
Oh, okay.
I'm not much aware of uh, the things. Like once I start going through and then I start
So,
working out,
so
then yes,
yeah, that sounds good. Okay.
yeah,
Okay. So, so you can see my screen, right?
yeah,
Okay. Just give me a sec. By the way, I started recording this session right from the beginning, so
yeah. That's good. That's great.
So Manjush, today what we are going to do is that as per the syllabus, there are two things I want to cover. One is this lambda operations, okay, the third chapter, and then I want to touch base upon the file IO where we are going to see the examples, okay,
Okay,
and then tomorrow we are going to take the new Java datetime APIs, and we'll touch base upon the parallel streams concept also, okay.
okay,
All right. So before we move forward, let's just recall what we have learned so far. Okay.
okay,
So about the stream operations, as you know, that stream operations are divided into two major two categories. There are intermediate stream operations and there are terminal stream operations. Right.
okay,
Intermediate stream operations, they are always lazy. Okay, meaning
okay,
no code gets executed until there is a terminal operation.
okay,
Okay, all the stream operation which are intermediate in nature, they actually return stream itself, right?
okay,
Their signature, they return always stream type. So if we just go, so this is very important. It's a simple concept, but let me. So I'm going to show you this. So this is our intermediate operation, right? Map function,
okay,
and what
okay,
it returns is a stream,
okay,
correct? So all the stream operation which are intermediate, they actually return a stream itself.
okay,
But all the terminal operations, they do not return any stream.
okay.
Okay? So they return different things depending on what you are doing.
Hmm.
That part is clear, right?
Yeah,
Okay. So intermediate operations, they are always lazy, meaning nothing happens until a terminal operation is actually called. They always create a new stream because they are returning a stream, and a stream are always created new. They are stateless, meaning they don't do not store any state, right? For example, filter and map, for which we will take some examples again. There is some stream operation which are stateful, right? I mean, without state, they cannot actually give you the desired result, like distinct or sorted functions. Okay. So sorted,
okay,
if you are sorting a stream, then obviously you have to store. whatever has been sorted earlier, right? Somewhere.
Yeah.
So those are stateful stream operations. They are, only couple of them. Terminal I already told you. So so this part is clear, right? I mean, there is no doubt here. Hello.
Yeah.
So here you do not have any questions, right? Or
Actually, I don't remember everything.
okay.
Uh,
So that's okay. But I just, so that's the reason that I wanted to iterate, right? So let's see a couple of example of stream again, right? Just to
yeah.
recall what we discussed previously, right?
Yes.
So okay, let me take this filtering example. So last time when we had discussed, right, we had taken an example of some insurance use case, correct? Now,
Yeah.
in the link that I've shared with you, the GitHub repository, it has some examples. It has I'm showing the same piece of code. Most of the examples that you will see, they actually operate on a list of car, right? So the examples are simple. So cars have got a
Okay.
attribute. So car, if you look at the car has got an attribute, color. Another attribute is called brand, right? And one is model, and there is a cost,
Yeah.
right? So all the examples that I have actually created are operating on the list of car. So
Yeah.
if we take like the functional programming principles, then we know that all the functional capabilities, most of the functional capabilities of Java 8 are exposed via a stream interface, right? How do we get the stream
Okay.
interface? We get the stream interface by calling a stream function on the collection.
Yeah. Yeah.
And collection basically sets the context, right?
Okay.
So collection generally have a single type of object, right? And from that
Yeah.
type of object, stream is able to determine stream functions that on what kind of object I am actually operating upon,
Okay.
right? So rather than in a functional programming, rather than creating an elaborated anonymous classes and implementing a function, which was possible in Java 7 also, right? What we do is, so if in Java 7 you can do this, right? I mean, if you, so thread is a classic example, right? So when you say thread, sorry, let's say it's a new runnable, correct?
Yeah.
Now, in order to instantiate this new runnable, you actually have to implement this function, this interface,
Yeah.
right? Runnable has only
Yeah.
one interface, which is called run,
Yeah.
and this is something that you will have to. So in Java 7, what you will have to do is this: public class, sorry, static class, my thread, which implements runnable, right? And then I do some stuff inside this, right?
Yeah.
And when I say, so if you see thread, right? Thread has two constructors. One is it does not take any argument. Another one basically takes a runnable. In order to create
Yeah.
runnable, you will actually have to create a class, right? And I will have to do
Yeah.
this, correct?
Sort of. Yeah. Yeah.
Or there is another way. If I want to write a shorter way, which was available in Java 7 also, I can do this. So I can pass a inline. I can create an anonymous class, right? So I can just get away from it,
Mm.
and I can give the implementation directly here, right?
Okay. 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 Okay.
So this was available in Java 7 also, but the thing is that with the help of Lambda function, we can do
Yeah.
even cooler things. So we can even shorter this. If we let me see if we can do. right?
Yeah.
This is something that you can do in Java 8, and this is the cool things. And this is what you will see in most of the functional programming languages, right? Including any other language on JVM like Scala or Clojure. This is the kind of syntax that you will actually see, because it makes your syntax, right, much shorter.
Yeah.
It only here you only have to write things which actually matter.
Yeah.
So this is what we did, and now if we look at this example where we say filter all cars for a particular brand, right? This is what this function does.
Yeah.
So in the functional programming, what we will do is first we will take the collection. On that collection, we will get a stream. So now we have our stream, and then we have to call some operations on that stream. So what we want to do is that we want to actually filter out
Mm.
the cars which only belong to a particular brand, right? Let's say BMW
Yeah.
or Nissan or whatever. So what we do is filter function is actually expecting some condition, that on what
Okay.
condition I should filter this particular cars, right? So I say, okay, I
Yeah.
will provide that condition in the form of a function. That function is basically nothing but it is actually a predicate, right? So that function is defined in the predicate. Now
Yeah.
predicate is a functional interface. We discussed that functional interface is an interface which has only one abstract method,
Okay.
right? So predicate is one of the four major interfaces. So one is predicate, another one is supplier, one is consumer, and then fourth one is function. So these are the
Okay.
four major interfaces that are part of java.util.function package,
Okay.
right? And we have, so once we go to predicate, we know that predicate will have only one function, right? Because it's a functional
Yeah.
interface. So this implementation of this function, which is Boolean test, this is something that I have to provide in my filter function, because filter is expecting, if you look at filter is expecting a predicate which operates on type car,
Yeah.
right? So what I do is that I provide implementation of this function using lambda expression, and in lambda expression I get this car object. It represents a car object. I can call it whatever, right? Last time we discussed, if you remember, I can call it whatever, right? I can even call it Manjush. Doesn't matter because it's the name of the variable,
Yeah.
right? And type of this variable is inferred from the context. What is context?
Yes.
Context is car list,
Yeah.
right? So what I do is I from the context it is able to infer that I am operating on objects of type car, and my predicate says that I should actually return a boolean variable, and that expression I have to provide. So expression that I have provided is I get a brand, car.get brand, and then I call equals ignore case on the brand that is actually being passed to me,
Yeah.
right? And after that, what I do is, okay, I say, okay, my filter activity is actually completed, right? And filter is basically an intermediate operation, right? Not a terminal operation, because filter returns me a stream,
Okay.
right? So nothing will happen until I call a terminal operation. Now, in this case, the terminal operation is the for each. So if you look
Okay.
at for each does not return a stream. For each returns a void. Correct?
Okay. Yeah.
So in this, so when if I have to execute this piece of code, then calling a terminal operation is necessary for me.
Yes.
So I do a for each, and in the for each I call another function called car.print. I can even remove this. I can call something else. I can give whatever implementation I want. It's like a function, and I say car.post. This is something that I did. But what we are doing here is that we have written only one line. If you want to do multiple lines, then what we can do is we can just put a curly braces and we can do some other
Yeah.
option. This is what we do.
Yes. Yes.
Right. So now what we have done is there are a couple of things that we did here. First is that we saw that how to work with the streams. we have to get a stream from the collections. Then we have to call a intermediate operation. Intermediate
Yes.
operations always return a stream and they always take some kind of input. The type of input is
Okay.
generally inferred from the context. Context is defined again by the source, which is the
Okay.
list of cars. Right? And depending on what intermediate operation we are calling, we will basically have to provide implementation for that particular function.
Okay.
Right? And that function is part of the functional interface that we just saw. So every time you want to do something, let's say you are coding today, right? And then you forget what did we discuss, right? So you think
Yeah.
about what is the operation that I want to do on a stream. Then you say, okay, what I want to do is I want to, let's say I remove this, right? What I want to do on this stream is I want to filter
Yeah.
on the basis of what I have to provide a condition, right? How do I provide that
Yeah.
condition? That I do not know. So what I will do is I will call filter, and then in the signature in the ID I will see, okay, filter actually takes a predicate. Then I do not know what a predicate is, right? So
Yeah.
immediately what I do is I browse to the, so I see what is the predicate. Now what I can do is I know that all the interface. So there are two things that I know about predicates, right? That predicate is a type of functional interface, and if it
Yeah.
is a functional interface, then it has to have only one abstract function. All I have to do
Yeah.
is provide an implementation for that abstract function. What that abstract
Yeah.
function is, I can just go to the java.util.function package and I can identify what does this predicate take. So it takes a boolean, right? So
Okay.
it returns a boolean and it basically takes input as some object. That object type of that object is defined by the context again, which is the list of cars,
Okay.
right? So I know that I have to provide, and if I go to the lambda expression as we discussed earlier. So if we look at, so should I pull out the slide, earlier slide?
Yeah.
Okay. Right. So if we remember lambda expression, then the more lambda expression has got parameter, an arrow, and a body, right?
Yeah.
So parameter, we know that parameter is something that will be inferred from the context. Arrow basically is a magical, uh, we can say, symbol, which is actually creating an instance of that interface, which earlier we had to do using the new operator in Java 7.
Okay.
And lambda operation basically takes a body. So
Yeah.
body is what we are providing here, and the body has to basically return a boolean variable, correct?
Yes.
Because filter is basically taking a predicate, and that predicate has only one function which returns a boolean. So from somewhere this implementation has to come, right?
Yeah.
And that implementation is something that I will provide. So what I'm saying that car dot get brand dot equals brand. I can do more complicated operations. Now I know that equals functions actually return a boolean variable, right?
Yeah.
So this is something that I can do. And if I have to do more complicated operation here, I can just do it, right? Now the only difference is I will have to return this. Earlier I didn't have to write any return statement because again it was inferred by the compiler, right? Because
Yeah.
equals returns a boolean and it takes a single input which is of type T. T is again decided by the context. So earlier I didn't have to write any return statement because it was compiler could identify, right? If there is only one statement, it has to return. correct? But
Yeah.
when I have put curly braces, after that compiler's intelligence just stop, and it is expecting that you will actually identify, because now you can have multiple statements, right? Compiler will know which statement you actually want to return. So you will have to explicitly tell that what is the value I want to return from my body of my function. And here I can have, if you want, you can even have a variable which boolean is same brand to this, and I can return this variable. So you can see, right? So I can write a proper function inside the body of lambda expression also. Correct?
Okay. Good. Yeah.
Right. So there is no restriction that you cannot you do this, you cannot do that. The restrictions which are there are the functional programming principle that you should not modify the state. Okay, you should only be dependent. So
Yeah.
as far as the state is concerned, the simple way of thinking about it is that I am operating only, I am dependent only on the parameters that are being passed to me. I am not doing
Okay.
anything with the external state. So for example, if I have a, what I mean by, I can have this, right? I can do this, correct?
Yeah.
So if I am writing a function where I started, operating on this, then that will be wrong. So this is something that we should not do inside the lambda expression, because they go against the concept of functional programming.
Okay.
Okay, so this is something that we should actually avoid, because now what we are doing, that we are mixing functional programming with states, and it may produce things, it may give you results which are totally unexpected. So what I will do is that I will write it.
Okay. Yeah.
I will just check in this also. So it's for your reference that in future when you go through the code, you are able to understand that what are the things which are actually important to keep in mind.
Yeah.
That's one thing. There is one more thing that we discussed. I want to touch upon that. So let's say what we are getting is, right, this. So what I have is a filtered stream. I do this. Okay. So in the first statement, what I did is that from the card list I get a stream, and then I do a filter. So in return, what I will get is a stream, right?
Yeah.
So it's a new stream for me, filtered stream. In fact, better would be that just to understand for your code. And what I will do is stream of car original stream, right? Original stream will be what car list dot stream. And from the original stream, I will get a filtered stream. Probably this is better, right?
Yeah.
So from the original stream, I get a filtered stream, and on that filter, so streams are okay, right? Nothing will happen until I call a terminal operation.
Yeah.
So on the filtered stream, I will call a terminal operation, which is for each, correct?
Yeah. Yeah.
And now you see that when I come from a object-oriented programming paradigm, then what I will see that filtered stream is an object, right? It is available to me in the scope anywhere I want.
Yeah.
Right, so there is nothing wrong if I start working on this object again, right? So let's say sometimes you get a feeling that okay, I have printed car, Now what I will do is I will print, let's say, once again. Okay. So there is no harm, right? When you look from a Java 7 perspective, this is what we have been doing all along, correct? So we can
Yeah.
keep working on the collections because this collection is available to me. This object is available to me. I can work upon it anytime that I want,
Yeah.
right? And now let me show you what's happening. Like what?
Uh, Marut, just for a minute, I'm getting a call. If you
No.
don't mind, can I pick that? It's
Yes.
an urgent one.
Yes. Please go.
Thanks a million. Thanks a million. Just 2 minutes.
Sure.
Hello. Hello.
Hi, Manjush. Welcome back.
Yes. So, yes. Thank you. Thanks a million.
Hi.
Sorry for disturbing.
No problem. So, right. So this is what I was trying to show you, right? Now, what I've done is something very simple. That on filtered stream, I have actually called for each function 2 times. Correct.
Yeah.
There is no complications about it. So let me. What I will do is first I will create a list of cars. So I created my test data. I have only one car so far, and what I will do is I will do filter brand, and full pass. So, right. Now
Yeah.
let me debug this program and let's see what happens. Okay. So this function got called. So I come to the filter stream. And you see what happens. Now if you look at the output, you get an exception. Java.lang. Illegal state exception. Stream has already been operated upon.
Okay.
Okay. So stream is like a if you want to understand it, think about the file stream. Okay.
Okay.
So you are working with files and you open a file stream, you read the data, and then after you are done, you basically close the stream, correct? Because you do not want to keep the file handle. And if you want to read that file again, then again you have to create a stream from the file using some API. Without that, you will not be able to again read that file. And the similar kind of concept is here. That once you are operated upon the stream, once you have called a terminal operation on the stream, that stream is actually closed. And once the stream has been closed, you cannot operate upon that stream. So, in a nutshell, you can only call one terminal operation on a stream only once.
Okay.
Okay. So, I will just do this. I will rather do this. Okay.
Yeah.
So, so briefly we have discussed, revisited what streams are, how to call functions on a stream, what are the things that we don't have to do in streams, what are functional interfaces, right? And then again we touched upon that in a functional interface, the instantiation of functional interface happens by the arrow operator, right?
Yes.
And arrow operator is a integral part of lambda. So lambda has three things. One is your input, one is the arrow operator, and third is the body of the lambda, what we call lambda expression. Right?
Yes.
And all the functional interfaces are defined in java.util.function. And in that package, all the interfaces have this particular annotation, which is called @functional interface. Right?
Okay.
Okay. So all the functional interface, when I have to identify whether it is a functional interface or not, then I have to look for this particular annotation.
Okay.
And all the functional interfaces have only one abstract function. Only one. That's the
Yeah.
bottom line to remember about. That's all.
Okay.
Right. Now, when we call, there are two types of operations on a stream that we do. One is intermediate operations. Second is terminal operations.
Terminal
In,
operations. Yeah.
so intermediate operations, they return you what? So that's a question for you. What do you think intermediate operations return?
Mm,
They return a stream, right?
yeah.
Correct. So they return a intermediate operation basically return a stream, and
Yeah. Yeah.
in order to execute our code, because all the intermediate operations are always lazy by default, right?
Yeah.
So they don't do anything until you call a terminal operations.
Okay.
So you call a terminal operation, and terminal operations do not return a stream. Either they will return a void or they will return a
Void.
null,
Okay.
or they
Yes,
will return
yes, yes.
something else.
So the term like the intermediate operation always return a stream, and the terminal, yeah, basically won't return anything because it's a void. Because
Right. So terminal operation will return you some result, right? So either that result will
yeah,
be void or that result will be some list or it will be map or something, right?
yeah,
So and in order when we call multiple operations on a stream in succession, right? So
yeah,
you call one operation, you call another operation, then you call dot, then third operation. You can keep calling n number of operations on top of streams, and this
yeah.
particular process is called creating a pipeline.
Creating a pipeline. Okay, 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 okay. Yeah, yes, yes, yes,
So multiple
yes.
operations chained into one single statement. It's called uh, pipeline. And one
Yeah.
mistake that people make while doing functional programming in Java 8 is that they try to put too much effort into writing one line code.
Okay.
Okay, so because it looks fancy, it looks cool, right? So 20
Yeah, yeah,
statements you say I will put only in one line, and that will
yeah.
make code very hard to debug and for you to understand when you go in future and read your own code.
Yes, yes,
So,
yes.
so one has to be basically sensible about it while using Java 8 features, right? So
Yeah.
at least that's my suggestion, but different people have different style of coding.
Concept
At
and
least that my
ideas. Yes.
okay. And then we saw that we cannot operate on one stream multiple times. We will get an exception at runtime.
Yeah.
This part I want.
Anyway, whether we write one line or two line, when it compiles,
Yes,
naturally, this all have to come up, right?
correct. Absolutely. So this is another example that I have, given. This is what I thought. I will just sorry, red thing I will do. So this is another example, filter by color, and there are other examples. If you walk through this trainer module, then you will see that for chaining, distinct, filtering, grouping, iterating, um, for method reference, for pipeline, for sorting, right? There are examples given basically. Okay, and I'm adding more for your reference, right? In future, whenever you check out, you can just see how to implement it. Okay.
Yeah.
Okay. So I believe that that we had a nice refresher about streams, right? And now
Yes,
what I'm
yes,
going
yes.
to do is, you want me to touch upon something else now?
Uh, no, it's okay. Once I go through the video and I will, once I start referring some more examples, then yes, if
Yes.
I have something, yeah, sure, then I will get back to you.
Sure, sure. Yeah, great. So now what I'm going to do is, so basically we have to see. So streams are a large topic, right? But we have to see what
Yeah,
are the most important and the basic things. Basic things
things, yes, yes.
are four core interfaces, as they are
Yeah,
already defined as part of the curriculum. One is predicate, consumer, function, and supplier. Okay.
yeah,
All other core interfaces which are there in the java.util.function, and there is a large number of it. If you see,
yeah.
you don't have to get confused by this. Okay, by the way, there are many interfaces here, but they are more or less a specific version of these four interfaces.
Okay.
Okay, so they are primarily, you can say, they are like derivation from these four interfaces.
Yeah.
For example, you have this by consumer, it's nothing but a consumer which actually takes two inputs rather than one input.
Hmm.
Okay, so consumer interface, for example, can take only one argument. So you pass
Okay.
a car, and on that car you are actually operating. You're calling a for each function that takes a predicate. That predicate has a one boolean operation. That takes only one argument. But in cases, let's say I am iterating on map, right? Or so map has got two values, right? Key and value.
Yeah.
So I need to have something, which can actually consume two types or two values. So this by consumer is generally used there. Okay.
Yeah.
I will show you an example if you want. I will show you an example what I mean by this. So that
In Java 8, actually, in terms of memory, then there is a concept of metaspace is being introduced, right? Rather than going with before it was like heap memory. There is no concept of heap memory, not heap memory. What I forgot. Uh, like all the, I'm talking not in terms of programming, in terms of the memory allocation, uh, like uh, before it was like all the all the strings will go on to uh, uh, yeah yeah in heap memory. So but now they have taken off that, and they have come up with a concept of metaspace. So only the class definition will go in that, not the not the string objects. Uh, am I right?
so yeah. So I mean, we can. So what I can do is that I can probably either refer you to some material, or maybe we can touch base upon it tomorrow. This specific topic for a little bit of time. We can devote like 15 minutes, right? And that will basically.
It's okay. It's okay. I just well, somewhere I read this article, so something that straight away that came into my mind. One something that Java 8, because whenever in Java programmers do this memory allocation of heap memory for the JDK, then this concept of metaspace is being introduced, and there is a tremendous change in the memory allocations from when compared to Java 7. Something that I read like that.
Yeah, yeah. So I think on the outside, yes.
Yeah.
Okay. So basically, now what we are doing is that I was going to show you an example of the buy consumer, and the reason for that is that how to utilize that, just to make you aware that it's nothing that has to be confused with. It's pretty simple concept, and what I'm going to have is, let's say, this thing, right? So what I did is, it's a very simple example, right? So what I do is that I create a car map, or I will rather call it brand. Sorry, my ID is stopped responding. Give me a second. What I do is that I am just creating a brand to car map, right? So rather than a list, now I have a map, correct? And on
Yeah.
this map, what I want to do is I want to print this map, right? So when I say dot for each on the map, what I get is a by consumer, not a consumer. So when I do the same thing on a car list dot for each, I get a consumer, right? So you see that the consumer is actually taking input as car, only one type of object. But when I do a for each
Okay.
on map, I get a by consumer. By consumer takes two types of arguments. One
Yeah,
is
two arguments. Yes.
because we are iterating on map, right? Will have two type of value. So
Yeah, yeah.
in this
Key and
case, it
value.
has been inferring that one type is the key type is actually string and the value type is actually car. So
Okay.
when I say for each, earlier what I was doing is this. Sorry,
Okay.
for each. Earlier this was my style of working, right? Creating a lambda operation.
Yeah. Pretty good. Yeah.
But now I have two values, right? So I cannot actually pass a C
Yeah.
because it is expecting a. So what I do is lambda expression that I will do is this brand comma car, and what I will do is
Yeah. Only thing is two value, two objects I have to pass.
yes, exactly. So
So
this is what I was
the
trying
first one will so the first one will be the key and the second one will be the value.
exactly.
Hmm.
Right. So this is what I was telling you that the binary version of the predicates or the functional interfaces are not something extraordinary, right? They are
Hmm.
just the specific. They are handling a specific use case of the same four core interface: consumer,
Yeah.
supplier, function, and predicate.
Yeah. Yeah.
Okay? So just in case you start working with the map, so you will understand exactly what is going on.
Yeah.
Now coming to the lambda operation, if you see the first part is they say extracting data from an object using a map, right? So map, so I told you, right? Map, reduce, and filter, right? These are the three operations which are extremely important. Okay.
Yeah.
Based on these three functions, you can mostly do anything which is available in other functions also. So other functions are just again a special version of these three core operations. Okay, map, filter, and reduce. So map, filter, and reduce are something which is you will find even in big data technologies also like Hadoop. Okay, and these three operations are known by the same name across all the functional programming languages. Mostly their name is same. Okay, and what we are going to do, so map operation, what does map operation do? If you remember earlier, what we did is, so we get a stream from a collection, and when we do a map basically takes a lambda operation and it applies that function. The lambda operation nothing but an anonymous function, right? And it applies that function, it calls that function on each element inside that list. What I mean is, so let's say what I do is I get a car list and I get a stream I want to call map. So if you see map, it is taking a function, right? So what it does is it is taking, so first argument is always the input type. It is taking car as an input and it is returning an R, right? R can be anything. So what I am trying to do is that I want to get all the brands of the car, I want to change that to uppercase. Okay, let's say that's my objective. So I call a map function. Map function is taking a car, and what I do is I say car dot get brand dot to uppercase. Now I can call uppercase on this, and the reason for that is that uppercase is actually returning me a type of string. Correct?
Yeah.
So what I will get from this is, what do you think? What I will get from this?
I didn't get what you was asking. Sorry.
I'm saying that this line that I have written,
Yeah.
what will be the output of it? Can you try to make a guess?
Yeah. It will get in capital letters.
Yes,
Brand name.
yes. So I will get is a stream I will get a stream which will have brands with uppercase.
Yeah.
Yes, great.
Yeah. But it's
So
already in uppercase, right? Brand.
yeah, I mean it depends, right? I can write it in small also, right? I mean
Yeah,
nobody.
yeah, yeah. No, I was just telling. So the
Okay.
output will be the same. Yeah.
Okay, so basically, the whole concept of this is that I can apply this function will be applied on each element inside car list. That is the
Yes, yes,
primary
yes.
purpose of the map.
Yeah.
Okay.
Uh,
So we talked. So we saw that what map does. Primary function of what map is. It is to apply a function on each element inside the source.
okay,
And
okay. Just 1 minute. 1 minute. 1 minute. Car list somewhere I lost. Car list. Car list is yes. It's just a list and yeah. Okay. Yeah, yeah, yeah.
okay.
Car list dot stream of no. When it is a list, then we are calling stream. Then why again we are calling map? Somewhere I lost.
Okay. So basically, all the functional features are exposed by the stream interface, right?
Yeah.
So we
Yeah.
got the stream interface instance from carlist.stream.
Yeah.
Now, once we have got a stream, now we can call functional features of Java 8.
Yeah.
What we want to do is that we want to get all the cards, we want to get their brands, and then we want to change their brands to uppercase. Let's say that is the requirement, right? So what we do is that we call a map operation, and inside the map operation we pass a lambda, which is actually returning me an uppercase of brand. So I can return even anything else, right? I mean, if you want. Uh, Hello.